In this video, we're going to derive a formula for the centripetal acceleration in terms of angular speed. So in the last video, we derived the formula for a centripetal acceleration to equal the magnitude of the velocity, or in other words, speed, squared all divided by the radius. And in this diagram, we have a ball that's traveling in the counterclockwise direction, and I diagrammed the ball's linear velocity and centripetal acceleration. And we want to find a formula for our centripetal acceleration in terms of our angular speed. Well, in a previous video, we said that the linear speed is equal to the radius of a circle times the magnitude of our angular velocity, or in other words, our angular speed. So we can simply substitute our linear velocity into this formula, and we'll get that our centripetal acceleration is equal to the radius times the angular speed, which is all squared, divided by the radius. And this will simplify to the radius times the angular speed squared. And now we can use this formula to solve problems when we are given the angular speed and the radius. Now let's look at some problems. So in this problem, we have a rock attached to a string that is traveling in the counterclockwise direction. And we are told that the angular velocity of the rock is 5 radians per second. And we are told that the radius is equal to 2 meters. And we want to find the centripetal acceleration of the rock. Well, we learned that the centripetal acceleration is equal to the radius times the angular speed squared. So we can simply plug in our given values into this formula. So we have our centripetal acceleration is equal to the radius, which is 2 meters, times our angular speed, which is 5 radians per second, and this is squared, and this will give us a total of 10 meters per second squared for our centripetal acceleration. Now let's look at another problem. So in this problem, we have a ball that's traveling in the clockwise direction, and we're given the speed of the ball, which is 3 meters per second, and we're given the radius, which is 3 meters. And we want to find the centripetal acceleration of the ball. Well, we can see that we're not given the angular speed, nor the angular velocity. So what we have to do is plug in our given knowns into this formula so we can solve for our angular speed. So we have that our speed is equal to 3 meters per second. And this will equal our radius, which is 3 meters, times our angular speed. And we can divide each side by 3 meters to get that our angular speed is equal to 1 radian per second. Now that we have our angular speed, we can plug this into our centripetal acceleration formula to solve for our centripetal acceleration. So we have that our centripetal acceleration is equal to the radius, which is 3 meters, times our angular speed, which is 1 radian per second, which we squared that, and this will give us a total of 3 meters per second squared for a centripetal acceleration. So in recap, we learned that the centripetal acceleration of an object in uniform circular motion is equal to the radius times the angular speed squared, and is really helpful for problems when it only gives you the angular speed and the radius. Thank you for watching this video, and hope to see you next time.